Gravitational field at a point inside the cavity, and a cavity lies inside a solid sphere. We are seeing the big sphere, and inside which we are having the cavity. Okay, so the big sphere is having a constant density of mass m, well, whose radius is r. Okay, and the cavity what you are seeing here, which is the removed part, the removed portion forming a cavity. Okay, so forming cavity is of mass m and radius r, right? So whose radius is r. That means the capital R stands for the radius of this big sphere, and small letter r for the radius of this smaller sphere, which is removed later and which forms the cavity. And the mass of this big sphere is m, and this cavity is m, small letter. And now I am choosing 2 points, say O and O dash. So O dash is the center of this cavity, and O is the center of this solid sphere. So in this picture it is quite difficult to show you because these things are lying closer. There exists a point P which is inside this cavity at some distance from O dash. Okay, so now I am rewriting these things here. So say this is O, and this is our O dash, and here we may see the position of the point P. I can simply write the position vector of the point P with respect to O as x, and position vector of P with respect to O dash as this one, which is say some y, and the distance between O and O dash, otherwise the position vector of O dash with respect to O is this one, which is a. So now I have to rewrite the expression for gravitational field at point P. Gravitational field at P is now can be evaluated like this. So this is equals gravitational field due to the complete sphere, okay, so minus gravitational field due to the mass to be removed, forming the cavity. So this is G, mass removed. So now what I have to do is, so Gp is equal to, so how much is G sphere? From our previous derivation, I can simply write minus G into m divided by r cube, and it should be multiplied by the position vector where actually we are finding the gravitational field, that is at P. So with respect to the complete sphere, that is center of the complete sphere, the position vector of P is x vector. So this is over. And now we have to think about this second part, minus one more time I should write minus G into what should be the mass of this portion, that I have to think. Okay, so this mass should be written like this. You also get the clue why actually I am writing like this from my previous videos. Okay, so this one, how you can write? So it is r cube into capital M divided by r cube. This thing is only the mass, and the radius of this smaller sphere is r cube, and it should be multiplied by the position vector of P with respect to O dash. So the gravitational field at a point P lying inside this cavity. So because we are later removing this mass. Okay, so with respect to O dash, the position vector of P is y vector, so that should be written here. Now combining all these results together, so it is Gp is equals minus g into m divided by r cube x vector, it becomes plus g into, so you can see r cube and r cube with small letter get cancelled. So g into m divided by r cube into y cap, right? So gp vector is equals, what I can write, it is minus g into m divided by r cube, and I am taking these terms as the common. So the terms which are left inside bracket is x vector minus y vector. So now you have to think further about the relation between x minus and x minus y. So look into this picture. Here what I can write is y vector is equals, it is x vector minus a vector. Okay, so from the law of triangle of vectors, I can rewrite this relation. So I need x minus y. So x minus y is nothing but x vector minus y vector. So I can take this a vector on this side. That means x vector minus y vector is a vector. Right. So I can rewrite this bracket as a vector. So gp is equals minus g into m divided by r cube into a vector. So we got a very important result here. That means to say, see what actually a vector is. A vector is nothing but the vector drawn from this O to this O dash. This is the direction of a vector. Now GP is acting in the opposite direction of this one, minus a vector. That is, so inside this the gravitational field is always, okay, at what direction? Opposite to a vector direction. That is, inside this cavity the gravitational field is always in the direction of minus a vector, that is opposite to a vector. So regardless of this position point P, so the gravitational field inside this cavity may look like this, you know. Here is the cavity, and somewhere here is the point O, and here is O dash, right? So this is the direction what I called a vector. From this derivation, the result what we obtained here, gm divided by r cube is constant, right? So gm divided by r cube is constant. This says the gravitational field at any point inside this is constant. Okay, so inside this the acceleration due to gravity, otherwise the gravitational field inside this cavity is constant cavity. This is cavity. Okay, so inside this gravitational field is constant, but acts in what direction? Acts in the direction opposite to a cap. That is, at every point the acceleration field, that is the gravitational field, is always acting in this direction. So this direction resembles the direction of a vector. This is right. Okay, so you should not think like this, you know. So this is the wrong interpretation, and this is O and this is O dash. Well, so if you connect these 2 points by the vector a cap, this is not the way how actually the gravity acts. Okay, this is not the way. So this is wrong. So that means acceleration due to gravity inside this cavity is only in opposite to a vector, and which is a constant and given by gm divided by r cube.